Firstly, I want to introduce about Gauss elimination method. Gauss elimination method is a systematic method for a solving system of linear equations. How is the Gauss elimination method applied? Firstly, we need to change the system of linear equations to an augmented matrix. Use elementary row operations and convert the row echelon matrix to corresponding system. Then, we can solve using back substitution. Next, what is inverse method? It is also a method for solving system of linear equations. For 2 by 2 matrix, we can use the given formula to find the inverse. For n by n matrix, we can use the elementary row operations.
So here is our problem statement. So the question is, Karina, Liana and Yaina went to the shop to buy a gift for their mother for Mother's Day. When they go to the store sells 3 gift sets. Set A has 3 pieces of hijab, a bucket of flowers, and a container of cookies priced at 143 ringgit. While set B has 2 pieces of hijab, a bucket of flowers, and 2 containers of cookies priced at 127 ringgit. Set C, which is priced at 206, has 5 pieces of hijab, a bucket of flowers, and 2 containers of cookies. Each bucket set will have fresh flowers and filled with some chocolates. What is the price for each hijab, bucket of flowers, and 1 container of cookies? Purpose of the study: to apply linear algebra in our daily life, to construct an augmented matrix based on the problem statement, to find the price for each item using Gaussian elimination method, and to obtain inverse matrix, and thus find the price using inverse method to compare the answer.
Okay, so the first method that we choose is the Gaussian elimination method. So from the question, we can take out 3 variables, which is x is piece of hijab, y is bouquet of flowers, and z is container of cookies. So the equation is the first one is 3x plus y plus z equal to 143. The second one is 2x plus y plus 2z equal to 127. And the third one is 5x plus y plus 2z equal to 206. So the first step, as we know, we need to apply ERO, which is we need to make sure every row have leading one and below leading one must be 0. So the first step I do is 1 over 3 R1 equal to R1. Next, R2 plus minus 2 R1 equal to R2. Then R3 plus minus 5 R1 equal to R3. Next, 3 R2 equal to R2. And then R3 plus 2 over 3 R2 equal to R3. And then the last one is 1 over 3 R3 equal to R3. So we can stop here because the matrix is already in echelon matrix. So here we need to read the matrix using back substitution. So the equation we get is, the first one is z equal to 31 over 3 equal to 10.3. Then the second equation we get is y plus 4z equal to 95. And as we know the value of x, the value of z, so we can substitute the value of z in the second equation, and we will get y equal to 53.7. And then to find the value of x from the third equation, which is x plus 1 over 3y plus 1 over 3z equal to 143 over 3. So as we know the value of y and z, we need to substitute in the third equation so that we get x value equal to 26.3. So here we can conclude that x equal to 26.3, y equal to 53.7, and z equal to 10.3.
In this slide, we are going to find inverse matrix of A. So we have matrix A that contains the elements that shown in the slide. If matrix 2 by 2, we can simply find the inverse using formula given. But how about matrix 3 by 3 and so on? Okay, in this case, we can find inverse matrix by form an augmented matrix with identity matrix that had been shown in the slide. Firstly, after we form an augmented matrix, we're gonna apply elementary row operations known as ERO and basically take the left side, make it look like the right side. Now, the operation we apply on the left side must be applied on the right side too. And whatever result is on the right side is going to be inverse matrix of A. So let's start. Firstly, we have to find leading one for row 1 by multiply row 1 with 1 over 3. And we have to make sure under leading 1 is 0 by minus row 2 with 2 row 1 and minus row 3 with 5 row 1. This method is same as the previous slide. The difference is when we have to change the left side into the right side. And the final answer will look like in the slide. To make sure that you are on track, you can check your answer by calculator. But remember, it's only to check the answer, not to find the answer. Thank you.
Next, inverse method. The given equation can be written in a matrix form as AX equals to B, where matrix A is 3, 1, 1, 2, 1, 2, 5, 1, 2, and matrix B is 143, 127, and 206. And matrix X is XYZ. To solve this equation using inverse method, we must use A inverse that we have searched earlier, that is 0, negative 1 over 3, 1 over 3, 2, 1 over 3, negative 4 over 3, negative 1, 2 over 3, and 1 over 3. Then, we use formula to find matrix X, which is matrix X equals to matrix A inverse multiplied with matrix B. The answer that we get is X equals to 26.30, Y equals to 53.70, and Z equals to 10.30. For the conclusion, linear algebra provides the theoretical for solving a wide array of problems. In our daily life, we can represent some situation into a linear equation. Solving system of linear equation can be addressed through methods such as Gauss elimination method and inverse. Based on the example explained before, both methods can get the same answer, but there are some situations where we can only use Gauss elimination method since inverse methods are less efficient for large matrices.